Okay, hello. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Nazri. This is my fellow teammate Muhammad Amirul dan Muhammad. Okay, today we want to discuss our project, which is a development of glucose level monitoring. Okay, the title of this project is we choose to develop a glucose level monitoring in the body, which it can dispense dozens of insulin. As we know, diabetes is a most metabolic illness, has affected millions of individuals all over the world. It is distinguished hypoglycemia caused by the abnormalities in insulin production. Insulin action of both apprometric employed to detect glucose because a preventive therapy or cure or cure of diabetes has yet to be found. Is presented by the most effective approach is controlling it. Monitoring the blood glucose level as a disease marker has shown increase of life expectancy by allowing diabetic to manage periods of hypo or hypoglycemia, giving them more control over their condition. Also eliminate the devastating side effect. The circuit includes an analog digital converter, which is connected to the glucose reflectance photometer for generating the glucose data signal, and data multiplexer, which connected to the output of the analog digital converter. With an output connected to the monitor means for controlling the signal transfer between the analog to digital converter. Uh, it means we monitor it continuously. Okay, in the program flowchart, okay, as we know, it has a start button, a glucose level sensor, the LCD display. Okay, if the glucose reach over 150, the buzzer will turn on for 30 seconds. If the glucose reach below 50, the insulin pump will turn on. If the glucose reach over 50, the insulin pump will turn off, and it will not run the system, and the insulin doesn't get pushed in the vial. Okay, next I pass to Muhammad Amirul.
Okay, thank you, Muhammad Farid. Okay, Assalamualaikum. My name is Muhammad Amirul. Okay, I will share about the project that my group has made for this project. We develop a microcontroller that can read the insulin in the someone body with diabetes and measuring the level glucose, then dispense the doses of insulin based on the exact measurement. Okay, in this simulation, we use buzzer because the buzzer will alert the user. Then the buzzer will turn on, and the insulin pump will turn on too, and the insulin pump will stop working. Okay, next, it on. When the buzzer turn on, the if the monitor the patient reading exceed to 150, the controller will engage the insulin pump and generate the buzzer. An alarm for a short duration. When the reading falls below 50, the insulin pump will stop and the buzzer will turn off. Okay, thank you. Next, I will pass to Muhammad.
Okay. Assalamualaikum Muhammad. The presentation with the project materials that we are using. So the first one is the Arduino Uno. As we all know, the Arduino Uno is a low cost and easy to use programmable open source microcontroller. So the second one is the Arduino Reveal board. It has three components. The first one it contains 5 the Arduino Uno main board. So the second one is it comes with 5 volt DC to DC booster. So it boosts the voltage from the standard lithium polymer battery, in this case, which is 3.7 volt to 5 volt for Arduino Uno usage. So the third one is to provide at least 1 amp current and an output peak of 1.1 current. So this output is very suitable for Arduino Uno and also for the stepper motor for functioning well. So this Arduino lithium polymer sheet has an overcurrent protection for the Arduino Uno, and it also has the under voltage protection. So it prevents the battery to discharge under voltage and further damages the battery. So next, we proceed on to the LCD. This is simple to show the reading of the glucose level and dispense the doses of insulin based on the measurements that we have recorded in the user. So the next part is the passive piezo buzzer. So this buzzer is to alarm the user if the glucose level reaches above 150 milliliter per gram. Next, we proceed on and off switch. So this is to control the power delivery into the circuit. We also have push button, which clears the memory and reboots the machine forcibly if anything wrong happens. So pair with this, we also have an LED. It is to give the indicator that the glucose sensor exceeds 150 milliliters per gram. So it is to confirm the piezo buzzer. Piezo buzzer. So we proceed on the battery. So the battery that we use have 300 and it is rated to be outputting 3.7 voltage, which can be boosted by the Arduino lithium polymer sheet and raises the voltage from 3.7 to 5 voltage. So next we have the stepper motor. It is paired with its driver. So this stepper motor functions to inject the insulin. So we next one we have the tube. So its diameter is 8 millimeter and the outer is 6 millimeter. It is enough for the insulin to pass through the needle from the machine. Next, micro needle. The micro needle is a very short and small needle. It is 6 millimeter in diameter. So the delivery of insulin into the subcutaneous tissue is reliable, and it also can reduce the risk of painful injection to the user. So the user will be experience less painful experience. So the last one we have the printing. So as we have explained the 3D model, we have printed it in a 3D model to be placing as a component placement. So the last part is the coding. So you can see our codings works perfectly and doesn't have any bugs. So thank you.